this video, we will cover the physics behind the hoverboard. We'll explain the background, how the sensors work, how the hoverboard stays balanced, and general motion. First, I'm going to tell you guys about the history of the hoverboard. Hoverboards were first created by Shane Chen in 2011. They are the offspring of the Segway. Chen had the brilliant idea to alter the Segway by removing the handlebar to make it more mobile and smaller to fit into cities around the world. By mobilizing the device, Chen brought a use to Segways which weren't seen as much popularity in the 10 years they've been out. Chinese manufacturers produced copies of Chen's handleless Segway without his permission, and this sparked their popularity. Hoverboards have been popular in China ever since 2011, but they're fairly new in the US.
Now I will tell you guys about the physics behind the sensors within the hoverboard. The portion of the hoverboard in which you stand on houses two sensors in each pad, which pick up readings that tell the hoverboard which direction to move. If you lean forward, causing your weight to be distributed more on the front sensor, the board knows that you're leaning forward due to increased force on the sensor. Since the sensor picks up increased force on the front pad, it knows to accelerate forward. The more weight you put forward, the faster it goes. If you release weight from the front sensor and transition your weight toward the back sensor, then you will move backwards. If you maintain your weight so that there is equal distribution of weight, then you will have reached equilibrium, resulting in no movement.
Within the hoverboard is a system of gyroscopes that work to keep it balanced. Gyroscopes resist attempts to change position, and a resistive force appears when any attempt to tilt or rotate occurs. Centripetal forces hold the gyroscope upright so that it maintains the orientation of the hoverboard due to resistive and restoring forces. Gyroscopes spin in multiple axes to ensure that no matter where you lean, the hoverboard will stay balanced and will not collide with the ground. When you shift your weight to move in a certain direction, you alter the gravitational forces acting on both you and the board. Without the resistive forces applied by the gyroscopes, these gravitational forces would cause the hoverboard to become unbalanced and you would crash. Centripetal forces cause the force to be directed towards the center of mass, which means any change in position are directed around the center, which makes them negligible. Now we'll talk about the physics behind the general motion and how you ride the hoverboard. In order to spin on the hoverboard, you must distribute your weight such that the majority is on one sensor, as shown here. One toe is down and one toe is up. The toe that is down has the majority of the weight, therefore it applies the force, causing the hoverboard to spin in that direction. In order to distribute your weight so that the majority is over one sensor, you must lean over one knee, as shown here. The rider is leaning over their right knee, therefore more weight and force are applied to the right sensor rather than the left. This causes the hoverboard to spin in a clockwise direction. Notice how the rider leans forward on their toes to pick up speed, and how they rock their weight to stay balanced on the board. In these clips, look at how the body is turned in order to spin on the board. Hoverboards can serve many different purposes. Some use them for transportation, while others use them for recreation and fun.